Let us start. Yesterday, I have gone through the meeting and identification. Before that, gone through the heating and humidification. Now let us go through another practical aspect of this type of heating and humidification process by steam injection. Now, steam is generally injected in the air in order to increase the specific humidity, as in the figure shown here. Now, this process used for air conditioning of the textile mills, where high humidity is required to be maintained. Now, the dry bulb temperature of air changes very little during this process, as shown in the psychrometric chart below. The steam is normally injected into the air in order to increase its specific humidity, as shown in the figure. Now, this dry bulb temperature of air changes very little during this process, as shown in the psychrometric chart below. Means dry bulb temperature, the temperature of the dry air, when very little, almost no moisture is present in the mixture. Now, this can be during this process of humidification, we see that dry bulb temperature doesn't change much. Now, Ms is the mass of the steam applied, and Ma is the mass of the dry air entering. These are the two different masses. Here, W1 is shown here as the specific humidity. Just 1 second. The specific humidity of W1 is given as the specific humidity of air entering here. The specific humidity of air entering. Where W2, the specific humidity of air leaving. So this is W1 is shown in the psychrometric chart, and this is W2, the specific humidity of air is leaving is shown. Means W1 specific humidity means the amount of the moisture content, amount of moisture present per kg of dry air, per kg of air, dry air, and this is the amount of where after the humidification, it is clearly shown this amount increases from W1 to W2. H1, enthalpy of the enthalpy or heat content of the air entering, and H2, enthalpy or heat content of the air leaving. The heating and now for the mass injection, W1, W2 is equal to and H2 enthalpy of the air entering, and H1 enthalpy of the air entering, and H2 enthalpy of the air leaving. Then HS is the enthalpy of the steam injected into air. Means three enthalpies we are considering: enthalpy of the air or heat content of the air coming in, heat content of the air going out from the our process, and enthalpy of the air steam injected in the air. Now, for the mass balance, we know W1 is equal to minus W2 is equal to MS, mass of the steam, divided by mass of the air. The W1, the specific, or that's mass of the steam is equal to mass of the air multiplied by the difference between the specific humidity. Means this is the amount of moisture is present here per kg after the humidification minus amount of moisture present per kg before the humidification, multiplied by the mass of the air coming in, which will be the mass of the steam which is absorbed, or mass of the air coming in. Means this is the weight in moisture per kg. So it is also moisture. If you multiply by the moisture, then it is a moisture kg of moisture at the leaving stream of air, and the moisture content, mass of the moisture present in the incoming air. And this is the difference is the moisture of the steam injected here. Mass of the moisture, mass of the steam injected in this system. So heat balance will be accordingly enthalpy H2 is equal to enthalpy H2 is equal to H1 plus MS divided by MA multiplied by HS. Means the mass balance multiplied by the amount of the enthalpy of the incoming stream plus incoming of the incoming air will be the enthalpy of the incoming outgoing air, which is H1 plus W2 minus W1 HS. Just 1 second, 22. Now, the atmosphere of air at 25 degrees centigrade, dry down temperature, and 12 degrees centigrade, well down temperature, is flowing at the rate of 100 cubic meter per minute through the duct. The dry saturated steam at 100 degrees centigrade is injected the atmospheric air at 25 degrees centigrade dry bulb temperature. This is the incoming air dry bulb temperature, and 12 degrees centigrade wet bulb temperature. This is flowing at the rate of steam flow is 100 cubic meter per kg through the duct. Now, the dry saturated steam at 100 degrees centigrade is injected here into the air stream at the rate of 72 kg per hour. The mass is also given here. So, the temperature of the saturated steam is 100 degrees centigrade, and its mass of the steam is also given as 72 kg per kg. Calculate the specific humidity of enthalpy of the air living air. Also calculate the dry bulb temperature, wet bulb temperature relative to the living air. So we have to straight away use the psychrometric chart. Given TD1 25 degrees centigrade, TW1 12 degrees centigrade. That is the enthalpy of the dry bulb temperature of the incoming air, wet bulb temperature of the incoming air, and velocity of the air coming in, temperature of the incoming stream, and mass of the incoming stream, which is converted into 1.2 kilojoule per minute. It was in kg per hour. It was converted to kilojoule per kg per minute. Now, from the psychrometric chart, what is given here? First, we have to know that the specific humidity of the living air. First of all, mark the initial condition of the air, that is at 25 degree dry bulb temperature and 12 degree wet bulb temperature. 25 degree is the point here, is the point of the psychrometric chart on dry bulb temperature scale, which is put at 25 degrees centigrade, and 12 degrees centigrade is the weight of the point of the wet bulb temperature. with the weight bulb temperature or the line on from the weight bulb temperature if or closer to the closest to it. So when these two lines are intersecting each other, we'll get the point 1. And now from the psychrometric chart, we find that specific volume of that the point 1 is given here. From the chart, you will get specific humidity as well as specific volume. At point 1, it is specific humidity is given as 0.035 and specific volume is given as 0.844 cubic meter per kg of dry air. Now, enthalpy at the point 1 from the chart is given as, if you drop a particle over the enthalpy line, you get H1 32 kilojoule per kg of dry air. Now, the mass of air flowing. Now, Ma is equal to mass of air flowing is the velocity of the air, velocity of incoming air divided by the specific humidity of the air. The velocity of incoming air divided by specific specific volume of incoming air. We know that W2 is equal to W1 plus MS by MA is equal to 0.0034 plus 1.2 multiplied by divided by 1 on 8.5. This is we got Ma, so we got the put the value of Ma here, or we got the Ma steam here. It's given as 1.2 kg per minute, and so W1 is also available here. So W2, the specific humidity of air at the point of leaving is given as 0.01345 kg per minute, which is given as a temperature of the outgoing air. Now, enthalpy of the leaving air is H2. Enthalpy of leaving air divided by, from steam table, we will find that enthalpy of dry saturated steam corresponding to 100 degrees centigrade is enthalpy of leaving air. From the steam table, we got the temperature, dry saturated temperature according to 100 degrees centigrade. From the steam table, we get HS 2676 kilojoule per kg. So this is available. HS is available. We have the mass of steam coming in and mass of the air coming in. So both are available here. Plus H1 is available here. So H2, the enthalpy of the outgoing air, is available as 61.3 kilojoule per kg of dry air. Next, we have to find out the dry bulb and wet bulb temperature of the humidity and the relative humidity of the leaving air. Now, mark the condition of given psychrometric chart as 0.2 corresponding to wet bulb. So as per W2, we plot the chart at W2 and we know H2. H2, we can drop a vertical here and we can drop a horizontal line from W2. Both will intersect at a point. Now, from this arbitrary point, we'll get the point 2. The dry bulb temperature from this point, if we drop a vertical to the dry bulb scale, we'll get 26.1 degrees centigrade as dry bulb temperature. And if we drop a vertical on the wet bulb temperature, or we find out the nearest wet bulb temperature line, which will match with either match or closest to it, which will be equal to 21.1 degrees centigrade. And relative humidity of the living air is phi2 is given as 62%. Means relative humidity, we have to, this point is closest to the relative humidity line, which will be, that is 62%, which is closest to the relative humidity line. Closest to the relative humidity line on psychrometric chart. Next, 23. The moist air enters the chamber at 5 degrees centigrade, dry bulb temperature at 25 degrees centigrade, wet bulb temperature at the rate of 90 meter cube per minute. The barometric pressure, the moist air enters a chamber of 5 degrees centigrade dry bulb temperature and 25 degrees centigrade wet bulb temperature at the rate of 90 cubic meter per minute. The barometric pressure is, so dry bulb temperature is 5 degrees centigrade is given, 2.5 degrees centigrade wet bulb is also given. Rate of air, incoming air is given as 90 cubic meter per minute. The barometric pressure is given as 1.0135 bar. While means this is the atmospheric pressure given. While passing through the chamber, air absorbs sensible heat at rate of 40.7 kilowatt and picks up 40 kg per hour of the saturated stream. So saturated stream MW is given here as 40 kg per hour, which you are supposed to convert in 40 kg per minute. And the air absorbs sensible heat, HS is given as 47 kilowatt. And temperature is given as 110 degrees centigrade. From here, we'll get the from the steam chart, we'll get the corresponding enthalpy of the saturated steam from the steam table. So you have to calculate dry bulb and wet bulb temperature of the living air. Here we are having a psychrometric chart here, which is given dry bulb temperature TT1 as 5 degrees centigrade at the incoming air. Temperature, wet bulb temperature TW1 is 2.5 degrees centigrade and V1 90 cubic meter per minute. Thus, PV is equal to 1.013 meter bar is QS is equal to 40.7 kilowatt. And thus, QS is equal to 40.7 into 3600. 3600 kilojoule per kg is equal to MS 40 kilojoule kg per hour, and TS is equal to 100 degrees centigrade. MS is the mass of the stream coming in 40 kg per hour, which is converted from the given mass of the stream, which is given as kilojoule per kg. No, it is the heat content or sensible heat content of the stream coming in. Now put the dry bulb and wet bulb temperature of the living air, the TT3 and dry bulb wet bulb temperature of the living air. So we have to calculate the dry bulb and wet bulb temperature of the living air. Now this is given. First of all, mark the initial condition of air, that is 5 degrees centigrade dry bulb temperature, 2.5 degrees centigrade wet bulb temperature. So we put in 5 degrees centigrade here, got a vertical here, or got the line of the dry bulb temperature line from 5 to 1 degree. And then 2.5 degree, we got the, we find out the line of 2.5 degrees centigrade wet bulb temperature scale or closest to it, and this two line will match at the point 1, giving us the point on incoming of by the steam condition or enthalpy condition of the incoming air. This point will tell us from the enthalpy terms H1, and this will tell us W1, the specific unity line. Now, the point 1, 2 is a sensible heating of steam, and line 2, 3 represent the injection of steam. From the centimeter chart, we know that we'll get from the point 1 the specific volume of the air at point 1. That is, from the chart we'll get 0.792 cubic meter per kg. The specific humidity of air at point 1 is W1 is given as 0.0035 kilojoule per kg. This is available from the humidity chart. Enthalpy of the point 1 is given as H1, 13.8 kilojoule per kg, available from the psychrometric chart. Now, the mass of air flowing is given as the mass of the air the velocity of the incoming air divided by specific volume of the incoming air, which is this ratio will give us 113.636 kg per minute. Is 68.1 kg per kg is the mass of the air inflowing. The specific humidity at the point 3 will be given like this. The specific W3 is equal to W1 specific humidity at the point 1 plus ratio of the mass of the steam divided by ratio of the mass of the steam injected divided by ratio of the mass of the air coming in. So both we put it together and put together as, and we'll get fine. And where the mass of the steam injected is given here. Picks up a 40 kilojoule per kg of surrounded air. Here 68.8 kilojoule per hour it is given, and 40 kilojoule per hour is the mass of the steam injected given in the problem. So both these together, and after the calculation we'll get 0.0094 kg per kg of dry air. It's a specific heat at the point 3. From the steam table, we know the dry saturated steam corresponding to 100 degrees centigrade, its heat content will be 2691.3 kilojoule per kg. From the heat balance, H3 will be H1 plus ratio of the steam, mass rate of the steam divided by mass rate of the air, multiplied by the enthalpy of the incoming, multiplied the heat content or the enthalpy of the incoming steam, plus the QS, quality of the steam, amount of steam injected divided by amount of air injected. This is the mass of, so 38.8 plus 40 by A plus enthalpy plus the heat content, the sensible heat content 42.7 divided by 68.80 multiplied by 36 kilojoule. Thus, these three together will become 51.1 kilojoule per kg is the net heat balance in H3. Mark the condition of living air on the psychrometric point 3 corresponding to W3, which you have already calculated, and H3, which you have already calculated. Both drop a particle. Now, from the point 3, from the psychrometric chart, dry bulb temperature given as 26 centigrade. If we drop a particle on the dry bulb line, and plus if we drop a particle with the other line, both dry bulb temperature line and wet bulb temperature line will be available here. Just 1 second, please. Give me a slide. Now 24. Now, an air indication system, air conditioning system is to be taken at outdoor air at 10 degrees centigrade. Air conditioning system is taken to outdoor air at 10 degrees centigrade and 30% humidity at a steady rate of 45 cubic meter per minute. And to condition, it is 25 degrees centigrade and 60% relative humidity. And air conditioning system is to be taken in outdoor air equal to 10 degrees centigrade and 30% relative humidity at a steady rate of 45 cubic meter per minute. Taken in outdoor air at 10 degrees centigrade and 30% relative humidity at a steady rate of 45 cubic meter per minute. And to condition it to 25 degree and 60% relative humidity. So outdoor air is taken at 10 degrees centigrade, means this is the dry bulb temperature, and 30% is the relative humidity of the incoming air. Now, rate of coming in of the incoming air is 45 cubic meter per minute, and to condition taking So this is the condition we are taking in, and you are making it the condition up to 25 degrees centigrade. That is the how dry bulb temperature outgoing air and 60% relative humidity. We have increased it from 30 to 60%. The outdoor air is first heated to 22 degrees centigrade in incoming in the heating system, then humidified by the injection of hot steam in humidifying system. First, we have to heat it, then you have to humidify it by sending the steam. Assuming this entire process takes place is at a pressure of 1 bar, determined without using the psychrometric chart. The rate of heat supply in the heating air and the mass of heat the rate of heat supply in the heating section and the mass flow rate of steam required in the humidifying section. So you have to do it without using the psychrometric chart. So what is given? The dry bulb temperature is given. Relative humidity is 30%. Relative humidity is given. Is equal to 0.3. Velocity of the incoming air is given, and dry bulb temperature, the outgoing is given. Relative humidity of the outgoing air is also given, and dry bulb temperature at the incoming and the moisture is given. TD2 and PB 1 bar is also known. First of all, mark the initial condition of air at 10 degrees centigrade. At 10 degrees centigrade dry bulb temperature, 30% relative humidity on the psychrometric chart at 0.1. It is we are using this psychrometric chart here to find out the different points. Then mark the final temperature of the air at 25 degrees centigrade at 0.3. So first we have to point 10 degrees centigrade here and 30% relative humidity line on it. So this is we have got to 0.2. At 25 degrees centigrade and 60% relative humidity line. This is on the 0.2. Draw a vertical intersect here. Draw a vertical intersect here. 2 points are available here. Now the foundation in line 1, 2. Line 1, 2 represents the heating of air in the heating section, and line 2, 3 represent the humidification air in the injection of hot steam. So we are having, first we are heating the steam, then we are humidifying the steam. In PVW, we want partial pressure of water vapor at dry bulb temperature 10 degrees centigrade. PV1, partial pressure of the water vapor at dry bulb temperature 10 degrees centigrade. Then, from steam table, you know the saturation pressure of vapor corresponding to dry bulb temperature, dry bulb temperature of 20 degrees centigrade. Saturation pressure will be PS1 at 0.01227 bar 1227 Newton per meter cube. From the relative humidity line, we know velocity of the PV1 divided by PV1 partial pressure of the water vapor divided by the partial pressure of the steam over the whole steam. Partial pressure of the vapor divided by partial pressure of the PV1 of the water vapor. There is a partial pressure of water vapor divided by partial pressure of corresponding dry bulb temperature. Saturation pressure, sorry. Partial pressure of the water vapor divided by saturation pressure of the water vapor at the dry bulb temperature. So that is the relative humidity. So PV1, the partial pressure of the water vapor, will be given as PS1 multiplied the relative humidity is equal to 0.3.012227. Is equal to 0.003681 bar or 361.8 Newton per meter square. And the specific humidity at 0.1, W1, will be given by this equation 0.0622 PV1 divided by PV minus PV1. So 0.622, 0.003681, 1.003681. 0.0023 kg per kg of dry air, W1. We know that the pressure of dry air the specific 0.1 is available from this equation. So now this pressure of the dry air will be given as pressure of the paper minus the pressure of the mixture divided by the pressure of the paper minus the pressure of the paper. So 1 minus is the pressure of the dry paper. Dry air will be 96631.9 kilonewton per meter. So specific volume of dry air is given as Vs1 is R into TD1 divided by PA. Then RA is 2.87, TD1 is 10 degree plus 273 degree divided by PA is equal to 0.815 cubic meter per kg. So mass of air flowing in is given by the velocity of the air flowing divided by velocity of swim. This is at 45 there, 0.815, 55.2 kilojoule kg per minute. And mass of the flowing air, thus is the enthalpy of the air at point 1 should be enthalpy H1 is equal to the specific heat multiplied by the temperature right is the 10 degree. W1, the relative humidity is available already calculated, multiplied by 2500 plus 1.9 into TT1 is the temperature of the dry bulk air, which is equal to 15.84 kilojoule per kg. Enthalpy at point 2 is 1.005 into TT2 plus W2 with 2500 plus 1.9 TT2. So 1.005 into 22 plus 0.0023 multiplied by 2500 plus 1.9 into 22. 23.96 27.96 kilojoule per kg. Now the rate of heat supplied to the heating section. Now the rate of heat supply should be mass into multiplied by the change in enthalpy. Mass of the steam is given to 55.2 and enthalpy of 227. Enthalpy of 0.27 minus enthalpy of the incoming point 15.84 is 669 kilojoule per kg. 27.96 calculated here and enthalpy at 1 is given here 15.84. The mass flow rate of steam required in the humidified section, that the partial pressure PV3 of water vapor dry bulk temperature 25 degrees centigrade is the dry bulk temperature of the outgoing air. Steam table, we know the saturation pressure of vapor. Saturation pressure of vapor compared to dry bulk temperature or dry temperature is 25 degrees centigrade. This is the saturation pressure is given as 0.03166 bar, 36966 Newton per meter cube. So the relative humidity is given as the partial pressure of the water vapor, partial pressure of water vapor, partial pressure of the water vapor at saturation pressure of the water vapor. Partial pressure available divided by saturation pressure. That is the relative humidity. So given as 0.6. So partial pressure of the water vapor dry bulk temperature is given as 0.6 into PV3 or 0.6 into 0.03166 is 0.019 C. So the specific unit of 0.3 is W3 and 0.0622 PV3. 0.0622 PV3 divided by PV minus PV3. So 0.0622 into multiplied by 0.019 divided by 1 minus 0.019, 0.012 kilojoule per kg of dry air. So mass of the steam injected is given as increase in moisture content from 0.22 MA W3 minus W2 0.55 0.012 minus 0.023 0.523 kilojoule kg per minute. Let's come to the next problem. Just a second, please. Next is 36.25. At atmospheric pressure, a dry bulb temperature, atmospheric at a dry bulb temperature is 16 degrees centigrade and 25% relative humidity passing through a furnace and then through a humidifier in such a way that final dry bulb temperature is 30 degrees centigrade and 50% relative humidity. Find the heat and moisture added to the air. Also determine the sensible heat factor of the process. Now given TT1 is on 16 degrees centigrade, TT1 is 16 degrees centigrade, phi 1 25 degrees centigrade, TT2 30 degrees centigrade, phi 2 25%. Now, first of all, we are supposed to mark the initial condition of air, that is at 16 degree dry bulb temperature and 25% relative humidity. In the psychrometric chart, it is 16 degree calculated from here, from the abscissa, which is 16 degree, and relative humidity is 25%. Giving and this particle from 10% will be added to 0.1. We'll meet at 0.1. Then mark the final condition of air 30 degrees centigrade dry bulb temperature and 50% relative humidity on the psychrometric chart at 0.2. Now look at the point A. Next is final dry bulb temperature is given as 30 degrees centigrade here and 50% relative humidity. It is a particle here. It will intersect at a certain point with the 50% relative humidity line, which is the 0.2, which is the dry bulb temperature point, outgoing temperature point. Now we got these 2 points. We have to find the heat and moisture added to the air, also determine the sensible heat factor of the process. Now we've got 0.1 and 0.2. The marks. First of all, mark the initial condition of, okay. Now look at the point A. This is here. Look at the point of it by drawing a horizontal line from 0.1 and drop a particle, and which will intersect the vertical line from 0.2. Then somewhere we'll get the enthalpy at 0.2 at 0.1 is given as H1 is given 23 kg per kg. H2A, that is 338 kg per kg, and H2 364 kg per kg. So heat added in the air, H2 minus H1, heat added to the air 63 minus 23, 41 kg per kg of dry air. Moisture added from the psychrometric chart, it is W1 is available on the 0.1, 0.0026 kg per kg dry air, and the specific 0.2 is 0.0132 kg per kg of dry air. So moisture added W2 minus W1, 0.0132, 0.0026, 0.0106 kg per kg of dry air. The specific heat factor the sensible heat factor of the process is given as HA minus H1 divided by H2 minus H1, 38 minus 23 divided by 64 minus 23. That is 0.36366. Next problem, 16.26. What is given here? The air at 10 degrees centigrade dry bulb temperature and 90% relative humidity is to be heated and humidified at 35 degrees centigrade dry bulb temperature and 22.3 degrees Celsius wet bulb temperature. So initial dry bulb and humidity is given, so we can get the point, and final dry bulb and wet bulb temperature is also given. We can have the point here. Then given TD1 10 degrees centigrade, phi1 90 degrees 90%. No, the air is preheated sensibly before passing to the air washer, in which water is recirculated. The air is preheated, then it is passed through the air washer, in which water is recirculated. The relative humidity of air coming out of the air washer is 90%. This air is again reheated sensibly to obtain the final desired condition. Find the temperature to which the air should be preheated, the total heating required, the makeup water required, and the humidity efficiency of the air washer. So input temperatures and input points is given from diagram and theoretic humidity, and output point is also given. Now, air first preheated sensibly before passing to the air washer, in which the air is recirculated, water is recirculated. So, relative humidity of the air coming out is 90%. So, relative humidity of the air is become 90%. This air again reheated sensibly to obtain result. Humidity of air coming out again reheated to sensibly obtain the final desired condition. So, temperature to which air should be preheated, the air total heating required, makeup water required, and the humidity of the air washer. This is you have to supposed to know. TD1 is given, phi1 is given, TD2 is given, TW2 is given. Means dry bulb temperature incoming, relative humidity income is given. So the initial condition, map the initial condition, say 10 degrees centigrade here on the psychrometric chart of dry bulb temperature. Line drop a vertical intersect at 90% relativity line. Next on the psychrometric point, so point 1 is available. Then the final condition 35 degree dry bulb temperature here and 25.2 degrees wet bulb temperature is here at the point is or 2 is available. So initial and final point is available. Now the process. Now point 1 we have to draw a horizontal line to represent sensible heating, and from point 2 and trying to draw a horizontal line to intersect 90% relative humidity line, which is given here, that line which is available from here. Both is from one, it is available from here, and this is from here. Now point put constant wet bulb temperature line 90% and point B best. Now from B draw a constant wet bulb temperature line which intersects the horizontal line. This is the wet bulb temperature line, intersects the horizontal line drawn through the point 1 at A. So this line H2 will, if we draw, it intersect the horizontal line coming from A at the point 1 A. The line 1A represents the preheating, and line AB represents the humidification. Line B2 represents the reheating of the final condition. So what that we have to do, we have to find the points of A and B. The temperature at which air should be preheated from point A, it is available. TD is, if we drop a vertical here, we'll get the dry bulb temperature at point A. And if we drop a enthalpy, vertical enthalpy line, at enthalpy at point 1 is available. Enthalpy at point A is also available. Enthalpy point H2 is also available. Now, the heating required for the preheating of the air, HA minus H1 is the difference between these two enthalpies, 23.8. It for reheating the air is also available, H2 minus H2, 17 kg per degree. So both these two heat is added together is the total heat added. Makeup water required from the segment chart we got W1, that is the specific humidity, and specific heat of leaving air, W2. So makeup part required, it is WB minus WA is equal to W2 minus W1. This is the difference between these two specific humidity, and it is given 0.0054 kg per kg of dry air. The humidifying efficiency of the air washer, from the psychrometric chart, we find that TDP 19.1 and TD2 18.8 degrees centigrade. The temperature of the dry bulb temperature at B and that at B dash is 18 degrees centigrade. What is B dash here? B, and if we got it from V dash, this is the dry bulb temperature here, and this is the dry bulb temperature here. The humidifying efficiency of the air washer, actual drop in dBA, ideal drop in dBA. So TDA minus TDB, TDB minus dBB. TDP and TDB dash. So if you put this together and make the ratio, we'll get 94.4%, which is the humidifying efficiency of the dry washer. So we are stopping here.